All right. Are you guys at a decent point to look at this? I think most of you guys are almost done. Let's do number 3 first real quick. So that kind of problem when I'm telling you I'm picking like 4 people or 5 cards or whatever. Guys, I always like to look at it like a hangman game. I got 4 people. I want to fill in the probability that they're whatever. So I got 4 spots. I want the first one to view North Korea favorably, right? And they thought we said IKEA. I don't know. What's the probability the first person views North Korea favorably? 0.09. And why do I not have to care about the next one changing, like doing kings out of cards and stuff? How many people am I picking on the last one? 5% rule, right? I'm only picking 4 people out of 320 million, all Americans. We're even including little babies. Why not? Hey, you. What do you think about North Korea? They suck. Okay. And then I want the rest of them to be okay with them. I mean, to be not okay, to have an unfavorable view. So what's probably that one person has an unfavorable view? Yeah, 1 minus this. So 0.91, 0.91. So the shortcut way to write that, of course, I got 1 person like that, 3 people like that. And then, of course, what's that?
0.067.
0.678. So what you guys got? All right.
Oh, the first.
All right, part B is the part that gave us all trouble. But let me ask you this. Tell me, what are all the things that could happen here? If I got 4 people and I'm talking about how many of them view North Korea favorably. You with me? How many things could happen? If I got 4 people and I'm like, how many of them view that North Korea favorably? So one thing that could happen is none of them do, right? So I could have none of them view it favorably, or what else could happen? 1, or, and of course I stopped there because I only have 4 people. If 5 of them like it, I'm like, who the hell is this? There's the ghost. And of course, if I add all these up, what do I get? 1. So I'm going to show you mathematically what I've been explaining to little groups of people today. I'll tell you the other way to look at it in case I didn't tell it to you yet. Here's the purely mathematical way to look at this. Can you help me underline the part up here that actually relates to part B's question, the probability of at least 1? What would that be up here? Where's the probability of at least 1? What would I include in the probability of at least 1? Yeah, this whole thing is at least 1. So if I want to solve for this, all I have to do is subtract P0, right? So remember, opposite probabilities. In fact, how did you guys get that probability right there? What'd you do? How'd you get 0.91 here? 1 minus 0.09, because opposite probabilities, 1 minus one of them is the other one. So the opposite of at least 1 is none. Therefore, mathematically, the probability of at least 1 is 1 minus the probability of none. You can always do that. Thank God. Right? What gets really sucky is if it says probably at least 7 out of 38. And I'm like, please, chapter 5, get here. Because in chapter 5, we'll figure out something really nice. Well, how do I do this probability? This means that none of them view North Korea favorably. So what would this probability be? Yeah, they'd all be 0.91s. They all view North Korea unfavorably. It's almost like a tongue twister. And then so I want 1 minus that to get the answer to my question. So that's interesting. Probability, you can always do this. If the opposite probability is easier to calculate, I'll do that and do 1 minus that. Hell yeah. So some of you guys, I appreciate some of you guys actually did this. Sort of. You actually need a lot more. Probably one, it could be the first one is favorable and the other ones are not. Or, and then, because do you see how each one of these, how many ways is there to do 2? the first two are favorable and the last two aren't, or maybe the middle two are not, or maybe the first two are not, or maybe, oh my God, each one of these has multiple ways to do it. You guys, good Lord, don't make me do that. So does the opposite probability have less to do? Hell yeah, there's only one way to have none. None, right? You don't like it, you don't like it, you don't like it, and so forth. And what do you get when you do this? 0.31?
0.31.
That's. I wasn't specific on this. Normally, I'm going to ask you to take it out 4 decimal places, like 2 percentage places. Does that make sense? So like this would be 0.3143 or 31.43%. Because when we get to chapter 6, all of our probabilities are going to be in 4 places because the chart we're going to use has them all out to 4 places. Cool. But the most important thing I want to see on this quiz is your work that gets you to that number. The less work I see and the more mistakes you make, the more points you got to take off because I don't know what the hell happened. You want to show me where things are coming from. Is everybody cool with part B then on number 3? All right. Okay. Let's look at number 2. Does anybody need this up here still? You guys got this? All right. You're right here. So here we go. Wait. So number 2, I've locked up. You know, there's always political problems. I figured I'd put them in a haunted house because I had a neat little graphic to show you guys. So the first thing you want to do in this kind of problem is how many total people am I talking about? Good, 21. And don't make simple mistakes like the person as a Democrat will not be 1 out of 7. And you guys see where that mistake comes from, right? Because they're thinking, I'm going to take a Democrat and there's 7 of them. But you got to think about the bottom always has to represent how many total things could happen. You got 21 people. And out of those, there are 7. So probability is all about the chances you have to do what you want. So if I want to to save a Democrat from this haunted house, this is a sentence you don't hear a lot. I have 7 chances out of 21 if I just pick somebody randomly for them to be a Democrat, right? So that's exactly what we call probability. It's neat. If you think about it that way, what we call probability is just the chances we have to do a certain thing. 7 chances out of 21, which of course is 1/3 or 33.33%. That's fine. Cool. Okay. Part B. What's probably a person is a Republican? 12 out of 21, which reduces to 4 out of 7, which is equal to 57.1? 4? 14. There it is. All right, cool. All right. How are we feeling? Yes, ma'am.
Are you going to be specific on what you want as an answer, as a percentage? Versus
On the quiz, I'm going to say decimals 4 places, percentages 2 places.
Okay.
And you see how I've taken it away now, but that's the same thing, right? Because once I move the decimal twice. You guys with me? But you desperately don't want to skip this. If you just give me a percentage and it's wrong, you're going to lose like all the points because I don't know what happened. So what about part C? Now I'm picking 2 people with replacement. So what's probably the first one is independent, and then the next one's Republican. So yeah, good. So I got my little hangman game. Independent is 2. It's always so few independents. Well, now it's more and more. And then times how many Republicans? What's probably Republican? 12 out of 21. Good. And then, of course, whatever the hell that is.
24 over
5.44%.
5.44? Yeah, okay. Cool. Now, what was my clue there as to what operation to use? What was my clue that, why did I multiply? Good. And basically means multiply, or basically means add. I like it. So when I'm talking about, now if I'm talking about one person, I have the numbers. That's why in part A and B, I could just give the probability straight up. But the minute I start talking about two people, now let me see if you guys get this. I don't have information about all the combinations that could happen. Do you see that anywhere here? I could come up with it, and I can do all the work, but why would you? It's easier to do the formula on number 2, and it's easier to not do the formula on number 1, because on number 1, I know every freaking thing. I can see everything, right? Hopefully. And of course, on number 1, I'm only picking one person, again, right? So what about part D? Still with replacement. 2 Democrats. So the first Democrat and the next one's a Democrat. I keep wanting to put that down. I need it. 7 out of 21, 7 out of 21. 0.11111. So 11.11%. Is that cool?
Yes.
Cool.
Thank you. I like feedback. Now if we do the whole thing without replacement. And I like doing this, asking the same basic questions. Be careful, don't always expect I will, but I normally do. Because I want you to see how it changes. If I do this same thing, but without replacement, what's the only thing that's going to change?
Total number.
Yeah, because if I take an independent and then free them from the house, right, so the ghost will leave them alone, then there's one less person, but there's still 12 Republicans, because I didn't take any of them, right? So for Part E, it's going to be, there's a chance the first one's independent, go home, and then there's still 12, but there's only 20 people. All right, cool. And then whatever that is. 472
5.5.
Yeah, okay. 5.71. And then Part F, how's Part F different? I got 2 Democrats, so the first one's a Democrat. It's still 7 out of 21? Good, because now I have one less person and one less Democrat. So one less Democrat, one less person. 10%. Cool. I like it. Cool. Now, let me take a step back here. This is the building blocks of probability. Are you with me? So a lot of you guys, if any of you are right now going, why would I ever need to calculate this? You wouldn't. I mean, this is the building blocks. We're going to use this to then make more meaningful analysis in Chapter 5 and Chapter 6 and so forth. Right? This is just how probability works. So now let's work our way back up to number 1. All right, so how many total people did we get in number 1? 166 total people. What's the only part of number 1 that won't have that on the bottom to begin with? E. Let me say this again. The only problem in number 1 that will not have a 166 on the bottom to start with, and then you can reduce it and whatever the hell you want to do, will be part E. Why part E? Because we know something about that person. It can't be all 166 people. In part E, it can only be business majors. So the bottom will reflect that, right? So the bottom is always the total number of things that could happen. And the minute you give me more information, less stuff could have happened. So the bottom's going to change. So 1A attends Grossmont. So how many Grossmont people? 126? 166, and you can make that into a percentage or whatever. If anybody did. 75.9. Part B, business majors. 78. You made it into percentage.
46.
Who?
46.9.
46.9. And part C. Now this is where we had some people not quite understanding, but computer science major or. So I know that or means I'm going to have a more than normal. So not only the computer science majors, they could also be Grossmont students. It could be one or the other. So my top should be larger than either one of them. I'm going to combine those. And the formula is multiply, but in general, and is going to have fewer and fewer. So I don't know if have I talked about the nice and mean bouncer yet? I don't think so. So I always think about and is the mean bouncer, right? He says, to get in the club, you got to have money, and you got to look nice, and you got to dress sharp, and your car's got to be nice, actually, because we don't valet any shitty cars. Right? And so how many people, fewer and fewer and fewer people, the one guy's like, I got money, I don't have nice clothes, because I don't have shit, and my car looks, I can't come in. Right? You kind of, so that's the mean, or if you ever looked, back in the day, we had to look through this giant book of scholarships, and I remember, nowadays they have internet and stuff, but you look through and I start to read, must be a math major, check, must have this GPA, check, must do the check, must be a woman, shit, right? And that was and, you must be this, and I'm like, put that first, what the hell? This actually is this true story, but and always reduces the number of things. Or if the bouncer said you got to have a lot of money, I don't. Or you got to dress sharp, I don't. Or you got to look good, I don't. Or you got to have a nice car, I do. Come on in, dude. Right? So then a larger and larger pool of people. I know it's a silly example, but it'll stick in your head. And reduces or increases the chances, the number of things that match what you're looking for. So part C, the smart way to do part C is I've got, for example, how many Grossman students? I got 126. I didn't put all the numbers on there. If I count all the Grossman students, how many computer science students have I not counted yet? 15. You can do it this way, or if you did 126 plus, I think it was 77. So if you do 126 Grossman students, 77 computer science majors, you've counted 62 twice. And of course, math says, dude, that is freaking 15, so math doesn't care which way you look at it. The numbers come out the same. This is the formula, but I don't have to do the formula because I have all the numbers. I could just do it quicker this way. What sucks is when people do a little bit of both. No, you got to pick one way to do it. Stick with it. So you end up with what? Let's see if I can add. And then whatever percentage that is. Cool. And then part D. Math and Cuimaca. And this, until you see it done, it's a little bit weird, but actually the funny thing is, I was trying to see if you did this, it was easy to explain it to you. I just said to you, where did the 62 come from? And who are those people? And then a light bulb went off, which is always nice. But in table form, any probability question is easy if you let it be. So how many students are actually both a math major and a Cuimaca student? Only 2. So if you see, the and is very often called intersection. You can see why. That's the intersection of those two things. So 2 students match both of these things. This is the mean bouncer, right? To get in, you got to be a math major. Yes, you got to go to Cuimaca. Shit. What club is this? Over. Beautiful. It's still 166 because it's not a given. I don't know shit about the student. It could be any of these people, right? And that's a mistake a lot of people make. They change the denominator too early. It's only when I give you information. It's the only time it's going to be different at the bottom. And you can make it into percentage, blah, blah, blah. What about part E? Now we got a given. So Grossmont, given, business major. So what do you know about the student? Oh shit, that's the symbol for given, by the way. We know that they're a business student because I'm asking the probability that they're Grossmont. Given that they're business majors, so how many are business majors? How many are business majors? 78. Out of those 78, how many match what I'm looking for? 55. Cool. So it's the one time the bottom changes from the beginning. Yes, sir.
D should be 11 over 166 times 40 over 166.
No, and we'll talk about that right now. You ready? If I said, let's probably pick a king and then another king out of a deck of cards. What happens to the probabilities as you move along? Don't they change? Let me say it again. So if I wanted you to pick two cards, two separate, distinct cards, and I want you to get a king, and then another king. That second probability, is it still 4 out of 52? It's changed based on what just happened. So in this problem, I don't even know how to change that second probability. I don't want to do it that way. Thank God there's a very easy way to do it. So this is the last thing I'm going to show you real quick, is exactly how to do it the way you're talking about. I still wouldn't do it that way, but in general, we need to know how to do it, because there will be problems where we have to do it the other way. So somebody look through your notes, or remember, what is the actual by-the-book formula for this? Kick ass. Right? Or and what's probably a B given A? I love it. Kick ass. The bottom, of course, is going to be the given, just like the 78 was because of the business majors, right? The bottom is related to the given. How are we doing so far? Now watch this. I don't think I did this last time. Solve for this, and we'll get a formula for and. How do I solve for probability of A and B? I multiply up, yeah. So probability of A and B, I can do it either one of these formulas, is the probability of A So for example, if I said probability of a king and then a king, I'm doing it by throwing the first one away. Are you with me? I want to show you how we've been doing this formula this entire time. What's probably the first one's a king? 4 to 52. I love it. Then I throw that king away. What's probably the next one's a king? And what is this officially? This is probably a king given that the first one was a king. Isn't that why it became 3 out of 51? We've been doing this formula since the beginning, just about. Right? It was just actually easier to not think of it as a formula, just to think of it as this is what happens, because it made sense. And then whatever the hell. So that is the formula for the probability of A and B. So if I wanted to do that here, let me write this as the probability of math and Cuyamaca. What would the formula look like for that? Yeah, probably math times the probability of Cuyamaca given math. Let's see if we get the same answer that we got up here. Let's see if we get the same answer. If we don't, we can throw all of this out. Forget about chapter 4 entirely. And somebody out there is like, there's a chance, there's a chance. Please, universe. It's too damn bad for you. The universe is not listening to your pleas. What's probability math major? Was probably a math major. Yeah, 11 out of 166. Now, what's probably of a Cuyamaca student given that they're a math major? So what's going to be on the bottom? Given that they're a math major. 11, right? Out of those 11, how many are Cuyamaca students? 2. What happens here mathematically? The 11s? And you get 2 out of 166, which is the same damn answer there. So the formula always has to work, but the formula is not always the best way to go. And it's very difficult for a student to understand, because you guys live off of formulas until now, right? Tell me the formula, I'll just stick some shit in it, right? And I understand, because that's the way that very often we teach it, which is really unfortunate, because that's not necessarily the way. So stats is very true to life. It says some situations it's just easy. That was easy. 2 people match what I'm looking for, I'm done. This is weird. This is difficult. More difficult than that. But it has to come out to the same answer. Okay, cool. So, next time, I'll fill in the definitions. If you guys have been looking at any of the homework, there's stuff in there about dependent, mutually exclusive, stuff like that. That's the definitions I'll fill in next time. I'll add that practice quiz for you. Okay.